Okay, so dilations. Anyone have any idea what a dilation is? Do you know the word transformation? Does that word sound familiar? What kind of transformations did you learn in IM1? I heard it. Rotations, reflections, translations. Okay, so a dilation is just a transformation. Okay, so a dilation is a transformation of a figure that results in either. So two things are going to happen with a dilation. So let's go back to IM1 for a second. For a rotation, you had a figure and it just turned, right? A reflection, it flipped. What was a translation? It just moves. It stays like exactly what it was. So if this is my calculator here, it just slides over. That's a translation. A reflection would be the flip. A rotation would be a turn. Okay? A dilation is when something gets bigger or smaller. Okay? So we use what's called scale factor to make our figure get bigger or smaller. We call those reductions or enlargements. So it's a transformation of a figure that results in either a reduction or an enlargement of the original figure. The original figure is called the pre-image. And we'll use all of this math vocabulary. So the original figure is called the pre-image. For instance, we would write it, so if we were talking about a triangle, it would be triangle ABC. If we were to write it out. If it's a square or a parallelogram, we would have a different, we wouldn't use triangle, but we'd have four sides. Okay, so it would be triangle ABC. And then the reduction or the enlargement, so the figure that happens afterwards, is called the image. This is my new figure. And if we were to write this one out, so for instance, again, if it's a triangle, we would write it as A prime. So it's just a little like dash up top, B prime, C prime, which is what you did when you talked about rotations and reflections as well. Okay, you still had pre-images and images. The blank is the ratio. So this is scale factor. And what's the ratio? What's the ratio? A fraction, right? It's our comparison of values. So in this case, it would be a comparison of the two figures. So the scale factor is the ratio of the lengths of the two corresponding sides of the figures and is expressed as a fraction or ratio, however you want to write that. They're the same thing. Okay. So based on our scale factor, we have a ratio that compares the side lengths. Now, when we're solving all of these, there's a specific way we're going to set up our ratio, and that is going to be our image over our pre-image. The image over the pre-image. Which one's the image? The new or the old one? The new one. And the pre-image is your original one, your older one. Okay? And you can tell, so if I look at these two squares, for instance, which one is the image versus the pre-image? Okay, image is the bigger one. How do I know it's the bigger one? It has the prime, which means this one is my pre-image. Now what we're doing when we're looking for scale factors, we're comparing side lengths. Because if I have something that starts with a length of 3 and now has a length of 6, I'm figuring out what happens. It obviously got bigger, right? So I'm figuring out how much bigger it got. So in this case, if we do our image, which is what? Our side length here is 5. So our image over our pre-image. This is my scale factor. I multiplied this ratio by 3 to give me 5. Okay. So we can either blow something up and make it larger or make it smaller and have a reduction. This number, if I were to write it as a decimal, what would that number be? Is it bigger than 1 or less than 1? It's greater than 1, right? So if your scale factor is greater than 1, that means your image is going to be larger than your pre-image. You have an enlargement. Okay, so actually let's write that. If the scale factor is greater than 1, you have an enlargement. If your scale factor is between 0 and 1, so that's a fraction, that would be like 1/2, 3/4, right? You're going to have a reduction. So let's identify in our next figure which one's which. Let's start there. So take a second, and I want you to identify which one's the image and which one's the pre-image. And I'd like you to write it in the triangle right now. You won't always have to do that, but I want that to be something that you kind of think about. So which one's the image and which one's the pre-image? Which one is this smaller triangle? It's your image. It's your new figure. And this one would be the pre-image. Remember to find scale factor. It's image over pre-image. So our image over our pre-image. I get 3 over 6. What does that reduce to? 1 over 2, 1/2. Okay, so I told you that if the scale factor is between 0 and 1, which it is, it's a reduction. Did I go from large to small? Yeah. Okay, so that's a good way to check yourself. If you get an answer that's larger than 1, then you should have a bigger figure that you resulted in. If you have a scale factor that's between 0 and 1, your new figure should be smaller. So it's a good check, because there's, again, not a whole lot of math right here. You just have to understand which one is which. Questions on image versus pre-image? No? Not too bad? Okay. So why don't you do the first one for me? I'm going to let you take a second, identify image and pre-image, and then see if you can identify the scale factor. And you can't see that, so how about I do that? There we go. Can someone from group E tell me which one my image is and which one my pre-image is?
The first one is the image for the prime, and the second one is the pre-image.
Okay. And how about someone from group C? Can you tell me what my initial ratio is for scale factor? 7 over 4, and does that reduce? No. Now 7 over 4, is that greater than 1 or between 0 and 1? Greater than 1, so what should be happening? An enlargement. Did I go from small to big? Okay, so again, that's how you're going to check yourself. So here is your scale factor. Now, on some assignments, they use the letter K for scale factor. Just an FYI, if you see K, it's talking about scale factor. I have no idea. And different books write it different ways, so I just kind of want to give you a heads up. I typically will ask you what the scale factor is, but I was just looking at your homework and they use the letter K. So now if you look at numbers 2 and 3, there's a whole lot of lines, right? You see a lot of information. There is a point out here, and this is called the center of dilation. So this point here is the center of dilation. And we're going to do an activity tomorrow. Oh no, we're doing a quiz tomorrow. Maybe Monday. That uses the center of dilation to enlarge and or reduce an image. So you should see your two triangles. Here is one, right? Q prime, R, or P prime, Q prime, R prime. And then PQR. Are you okay with that? So this one is my image, and this is my pre-image. Now, the distance from, and we can still do it the same way, we don't know the side lengths of the triangle, but we know the distance from the center of dilation to my image, and we know the distance from the center of dilation to that same point on my pre-image, right? Because they're both point P. So it's the image, which has a length of 3, and then my pre-image has a length of 6. This gives me 1/2. So based on that number alone, reduction or enlargement? Reduction, right? Because it's between 0 and 1, so this should be a reduction. Do I go from a large triangle to a small triangle? Or smaller triangle? Yeah. Okay, so you can use the center of dilation to also give you the scale factor. So you're either comparing the exact same side lengths or you're comparing the same distance from the center of dilation to the given point. Here is my center of dilation for number 3. I want you to identify the image and the pre-image. I want you to identify the scale factor, and then I want you to check that it is doing what it's supposed to do, so a reduction or an enlargement. So what one is this? My pre-image. And then the larger one is my image. So my ratio is 5 over 2. Image over pre-image. Is 5 over 2 between 0 and 1 or greater than 1? Greater than 1, so it should be an enlargement. Did my triangle get larger? Yes? Okay. So again, not a whole lot of math, but you can check yourself and make sure you are doing it the right way. Let's do a little bit more math, but it's still not a lot. All right, so we can also do dilations in a coordinate plane. So I give you the coordinates of the image. Which one's the image, the new or the old? The new, okay? Oh, I'm sorry. I don't give you, find the new one. I give you the coordinates of the pre-image. So I give you A, which is 6, 3. B, which is 6, negative 6, and C, which is 3, negative 3, 3. What shape or solid is, or figure is that? It's a triangle. It has 3 points, and this is my pre-image, right? I want to find the coordinates of the image, so I want to find A prime, B prime, and C prime. That's what I'm looking for. Do you agree with that? Yeah, or are you okay with that at least? Okay, and it says the scale factor, and again it uses K, is 4. So let's think about that for a second. It's 4, so my scale factor is greater than 1, which means what's going to happen? It's going to get bigger, right? You're going to have an enlargement. So if I were to graph, and I'm not going to do it for this one, we'll do it here. If I were to graph those 3 points, I'm going to have a triangle, and then when I find these new points, it's going to be a bigger triangle, right? So here we were already given side lengths and we found the scale factor. Now we're going to take the scale factor to find these points. If my scale factor is 4, I am just going to multiply each of my points by 4. So 4 times 6, 24. 3 times 4, 12. Okay, we're just making it 4 times bigger than what it already was. 4 times 6 is 24. 4 times negative 6 is negative 24. 3 times 4 is negative 12. 3 times 4 is positive 12. These are the coordinates of my image based on a scale factor of 4. We're just enlarging that figure. So it says for number 5, it says using the same coordinates, find the coordinates of the image of the triangle with a scale factor of 1/3. What's going to happen there? It's going to be a reduction. So let's actually see the reduction happen. So let's first plot points A, B, and C. So plot points A, B, and C on this graph. So 6, 3 is A. 6, negative 6 is B. And negative 3, 3 is C. So here's what your triangle should be. It's kind of hard to see. Let's see if I can. My little marker. You'll be able to see yours a little bit better. I'm trying to bold mine. Okay, so you can kind of see where my line is. It's a little dark. Now, if we're doing a reduction of 1/3, just like here where we multiplied by 4, we're going to multiply by 1/3 or divide by 3. Okay, it's the same thing. So 6 times 1/3 or 6 divided by 3 is 2. So it's 2 and then 3 divided by 3, 1. So my A prime is at 2, 1. Do the same thing for B. 6 divided by 3 is 2. Negative 6 divided by 3 is negative 2. And C, negative 3 divided by 3 is negative 1. 3 divided by 3 is positive 1. Plot those points on your graph. You should have a triangle that is 1/3 the size of the original one. You do? Good. 2, 1 is, and then as you're graphing, it should say A prime, so make sure you put the prime on there. Again, it's hard to see on mine. 2, negative 2 is B prime, and negative 1, 1 is C prime. So I went from a large triangle to a triangle that was 1/3 the size. These two types of problems are probably one of the most missed on this next test. I'm not sure why, but it's just a matter of multiplying your scale factor by those points. Okay, we started with basics with scale factor. Do we have any questions on scale factor? Okay, the biggest thing is also remembering it's the image, so it's your new over your old, over the pre-image.